So our Pythagorean trigonometric identities, the first one, sine squared plus cosine squared equals 1, comes from the Pythagorean theorem, because in the unit circle, it's all made up of triangles. That's how we get everything in the unit circle. If we go back to the introduction to the unit circle, all right, we talked about how the unit circle is made up of all different triangles with a radius of 1. All right, so from there, what you can do is you can rearrange the Pythagorean identities, this one in particular, so that different things are in front and then equal to something else. So these are the main trigonometric identities, right? Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared, okay? From there, we've derived 6 other things. Now, as we go through these examples, above the actual problem, I put all the possible things that we have been going over, all right, including these Pythagorean identities, the main ones. So as we go through this, I'm just going to be highlighting different things that we use to change things within the problem itself, okay? If you don't see, like let's say that I see cosine plus sine, you can't change that into the number 1. It has to say cosine squared plus sine squared, and then you could change it into 1. So do you see that in number 1, I have cosecant squared theta minus cotangent squared theta? I'm going to be using one of these. I want to use one of these Pythagorean identities, all right? Because it involves cosecant and cotangent, I'm probably going to be using this one. However, it's not in the right form, all right? So I need to convert the identity that I highlighted in purple into the correct form so that I can change the actual problem itself. So it looks like cosecant squared is positive. So I'm going to keep it positive on the right-hand side. If I move the cotangent over with subtraction, now I have 1 equals cosecant squared theta minus cotangent squared theta. So now this entire thing is the problem itself. So what is my answer to number 1? Because I can replace this entire thing. The answer is 1, and that's it. So all we've done today is add more stuff that we could change things into. Here we go, number 2. So we have sine squared plus cosine squared divided by sine x. All right, so I'm looking to see above if there's anything that I can change anything in this problem into. And I see that sine squared plus cosine squared is part of this identity. All right, this entire thing right here in the numerator is sine squared plus cosine squared. I can replace my numerator with the number 1. All right, so I'm replacing the numerator with 1, and then we have all over sine x. And now I have 1 over sine x, which is cosecant. So I used 2 different identities in this problem. I used a Pythagorean identity, and I did an original identity that we were used to. So my final answer is cosecant x. Now, is there any difference between me putting a theta or x, or if you flip through your notes, you'll see a capital A, or you'll see the beta symbol, all right? The symbol next to it, all right, does not matter. The only thing you're really changing is the trig identity, sine, cosine, tangent, secant, cosecant, cotangent. All right, what's next to it does not matter. All right, number 3, so we've got 1 divided by tangent squared x plus 1. So I'm looking in this problem, and I see that tangent squared plus 1 is right here, which is the same thing that's in my problem. So I have an identity that I can replace tangent squared. I can change it into 1 over secant squared. So I have 1 over secant squared x. This problem is an x in it, so I'm going to use x. You can use theta, though. It really does not matter, okay? Theta, T-H-E-T-A, theta. All right, so I've got 1 over secant. So if we look back at what we were talking about yesterday, which we talked about it yesterday, we barely used it, though. You do need to know this. All right, these ones on the bottom, fundamental identities. Sine is equal to 1 over cosecant, and cosine is equal to 1 over secant, right? Reciprocal identities. So right here in this problem, I've got 1 over secant, which is the same as cosine x. And that's my answer. Cosine squared x. Make sure you have the squared, otherwise the answer's wrong, so make sure you have that square. All right, number 4. All right, number 4. With all of this stuff, with these different trig identities, all rules go, all math rules. All right, so for fractions, fraction rules work. All right, multiplication, we multiply straight across, and we add. We have a GCF. We have to have a common denominator. So therefore, factor rules also work. All right, with this, I can GCF. Both of these parts, both these terms, have a cosine in common. All right, I have a cosine right here and a cosine right there. They're both squared also. So what am I going to do? I'm going to take out a cosine squared. So I'm going to write down cosine squared theta. And then I'm going to write down what's left over in the parentheses, which would be sine squared theta minus 1. That's how GCF works, greatest common factor. If I were to redistribute cosine squared, you should end up back at what you started with, okay? Right now, I see sine squared minus 1, all right, which is similar to this sine squared plus cosine squared equals 1. What we're going to have to do is we're going to have to manipulate this identity a little bit so that it looks like this, and then I'm able to replace it. If you look at this identity right inside of my parentheses, notice that sine squared is positive. Do you see that sine squared is positive? So in here, I'm going to have to keep sine squared on the left because it's positive on the left side. So in order to get this minus 1, I'm going to have to subtract 1 from both sides. So that it could go right there. But I'm also going to have to get rid of that cosine squared. Can I just do that at the same time, or do you guys need to see it separately? Okay, so I've got sine squared theta minus 1 plus cosine squared theta equals 0. This right now does not look like this inside the parentheses. So what I'm going to do is I'm going to subtract cosine squared on both sides. So that I have sine squared theta minus 1 equals negative cosine squared theta. So I just did a lot of subtraction, but now they match up. This is right here. So I'm going to replace what I have in parentheses with negative cosine squared theta. So I've got this cosine squared theta, and then I'm going to replace that with negative cosine squared theta. So this isn't subtraction. I'm not going to get 0. This is multiplication. I've got a positive times a negative. So my final answer is going to be negative. And then I have cosine to what power? The 4th power. Because 2 plus 2 is 4. So my final answer is negative cosine to the 4th theta. Okay, number 5. So I have cosine squared x times secant squared x minus 1. So right off the bat, I see that secant squared x minus 1 is similar to this tangent squared theta plus 1 equals sine squared theta. The problem is that one's on the left side in the original identity, and I need to move it over to the right side. So I'm going to use subtraction, minus 1, so that we have tangent squared theta equals secant squared theta minus 1. Do you see that now they're exactly the same? I'm going to replace secant squared theta minus 1 with tangent squared. So this gets replaced in the parentheses. So we've got cosine squared x times tangent squared x. What can I change tangent into? We can change tangent into sine over cosine. Except for instead of sine over cosine, it's going to be sine squared over cosine squared. So I'm going to change something else. I'm going to change that again. So I'm going to keep this as cosine squared x, and then I'm going to change tangent into sine squared x over cosine squared x. So I'm using another identity up top. With the cosine squared in the numerator, I can cancel it with the cosine squared in the denominator, and my final answer equals sine squared x. Next one. Right now we cannot use any of the Pythagorean identities because nothing's squared. However, when I change tangent, so everything else is going to remain the same. So we have cosine x plus sine x times, and then tangent is going to change into sine x over cosine x. All right, here's how fraction rules work. With multiplication, you can multiply straight across. I'm going to put sine over 1, and then we can multiply. So I'm going to rewrite cosine x, and then we've got plus, and then we've got sine times sine is sine squared x, and then 1 times cosine is cosine. The next thing that we're going to do is combine our two fractions into one fraction. In order to combine fractions, you need a common denominator. All right, in order to get a common denominator, I'm going to have to put cosine over 1 so that it is an actual fraction. If the right side has a denominator of cosine, the other side needs a denominator of cosine also. So we're going to multiply the numerator and the denominator by cosine. Now I have cosine times cosine, which is cosine squared x, all over cosine x. Don't cancel. Yes, I know that they cancel, but we can't cancel because we just multiply, so that we're able to combine these fractions. We've got plus sine squared x over cosine x. All right, so we just got a common denominator. The next thing that we're going to do is actually combine the fraction. So we have cosine squared x plus sine squared x divided by one single denominator. We're able to combine the numerators if they have the same denominator. So divided by cosine x. Almost done. That numerator is one of my Pythagorean identities. It's exactly like one of them. We have cosine squared x plus sine squared x, which means that I can replace it with the number 1. So I'm going to replace this with 1. So now I have 1 divided by cosine x. And my final answer, 1 over cosine equals secant x. So my final answer, secant x.